In this presentation, we're going to talk about a normal distribution and what it means. In front of you here is a sample of a hypothetical sample of heights of students in a class. Notice that the most students come out around 5'4", and then we have some that are 5'8", 6 foot, 6'4", and some that are shorter than that. And so we have a distribution of height, and it's a continuous distribution because some people might be 5'4½", someone might be 5'8¾". There's always something in between. If we observe how the mean and standard deviation affect the frequency, we did a finding mean and standard deviation previously. Let's take a look at this website. It's an interactive NormalCurve demonstration. And if you look here, we start out with a mean at 0 and a standard deviation of 1. So this is what we call a standard normal curve. Notice that if I move the mean, the curve tends to skew to the right. If I move the mean in a positive direction, the curve tends to skew to the left. Coming back to 0, if I can get myself back to exactly 0, notice what happens if the standard deviation is decreased. As the standard deviation decreases, or the deviation of each piece of data from the mean, the curve spikes even more than it does if it is less. The further out the standard deviation, the flatter the curve. Okay, so when you have a standard deviation which is a very small standard deviation, the curve is much more pronounced. And again, we can have a very pronounced curve, and if the curve, we end up with it slightly off center, off of the mean is going to change it. So keeping those things in mind, we're now going to take a look at what is a normal probability distribution. When we look at this, we have several important properties. First of all, notice that the curve is a bell-shaped curve, and with the highest point at the center, and we say that's mu, that mu being the mean of the population. Notice that it's also symmetrical. The left side here looks like the right side over here if we cut it right in half at the mean. The curve approaches the horizontal bar, but it never actually touches it because there's always the possibility of some outliers further out. The transition point where the curve starts to go, it goes up and then switches to downward, is here at the 1 standard deviation mark. The area under the curve represents the probability of, if I found a person, considering our height problem, if I find a person and what's the probability that they will be at a certain height or less than a certain height. Well, if we call this the cumulative area, because area equals probability. The cumulative area starts here at the negative point and starts working its way to the positive. If I have a point that is out here at 3.49, the cumulative, anything less than or equal to that, is very close to 0. As the area increases, the cumulative, the z-score also increases. Cumulative area. The cumulative area that is less than -1, that's this area here, is increased from the amount of cumulative area that is at a -2. As we approach z equals 0, being our z-score, we've approached 50, or half the area. As we continue to move on and we approach out here to 3.49, we've pretty much encompassed all the area. And for that area, the cumulative score is going to be 1. So how do you convert a problem into a z-score. Let's say that we have a problem where the average is 600 for whatever that is. It may be pounds, it may be time, hours, any number of things, with a standard deviation of 100. How do I convert the x value 700 into a standard normal curve? So I want to take this number and I want to put it into a standard normal curve. The formula for converting from a problem to a standard normal curve is z being the z-score, x 700 minus mu, which is 600, divided by the standard deviation, which is 100. So I end up with 100 divided by 100, and my z-score for 700 is equal to 1. And you'll notice that that makes sense. The 700 is pretty much in the same location where the 1 is on the standard normal curve. Thank you for this presentation. If you have any questions, please review it again.